everyone, good to be here. We're talking about multi-tenancy and how to isolate tenants, but also how to ensure tenant autonomy. You probably have not heard of Loft Labs. You've rather heard of vCluster, which is the project that we started in 2021. It's gotten pretty popular. A lot of companies are using it. We just announced our $24 million Series A led by Khosla Ventures. Thank you. There's a whole bunch of people using the project, 40 million Docker pulls, 5,000 GitHub stars, 3,000 people in our Slack channel. And all we care about is multi-tenancy and how do you make the experience for tenants better. And at the same time, reduce a lot of the friction that happens when you try to set up a multi-tenant Kubernetes cluster. There's a lot of Fortune 500 companies using us as well. And it's an open source project. We got it started in 2021, so about 3 years ago, and really excited to see the trajectory where this is heading. Today we're going to cover why multi-tenancy in the first place, right? Why not just use single-tenant Kubernetes environments? How to isolate tenants, how to ensure fair use, and then how to get that tenant autonomy. I try not to talk too much about vCluster and what we're doing and keep it more general, but obviously check out vCluster if you're interested. Why multi-tenancy? Well, this is a pretty convincing argument. Cloud spend is on the rise. Gartner predicts that cloud spend this year will be surpassing $679 billion, right? That's a lot of money. And when you look at the trajectory, right, 20% increase from last year, that is growing really, really fast, right? Most companies wish they'd grow that fast, right? And if you're looking at the latest CNCF kind of FinOps microsurvey, they asked people, what are the main drivers for that cost explosion? And unfortunately, to say Kubernetes is a main driver, right? So we should definitely double tap on Kubernetes cost. When you look at a lot of companies today, how they run Kubernetes, there's pretty easy way to spin up a cluster, right? Like in EKS and GKE, you run a Terraform script, and 30 minutes later you have a cluster, right? And that time was probably an hour and a half, 3 years ago, and it's getting probably further down and down. But what we can't really get rid of is everything that we're stuffing in each one of these clusters. So if we're creating a cluster, per tenant, per customer, or even per environment, prod, dev, staging, etc., we end up with hundreds or even thousands of clusters. That's the trajectory that a lot of companies are on. And in each one of these clusters, you have like a policy agent and a cert manager and an Istio and a vault, right? Like all of these different things needed to be deployed in a cluster, which we typically call platform stack. It's highly replicated. And it's super inefficient, actually, because most of the time this stuff runs idle, right? Especially in pre-production. And that's a big problem. When we're looking at the cost here, which is how I started this, there's obviously a cluster fee for each cluster. It's kind of the same in pretty much all cloud providers, right? Not talking about a cartel here or anything, but it's pretty interesting to note. Actually, Google was the only one that had no cluster fee for years. And then they realized actually running clusters is expensive. Everybody else is charging. So they introduced the cluster fee as well, right? It's probably their fault that we have so many clusters, because people are like, oh, these are free, great. But they're actually heavy to run. So multiply that by 1,000, then run this platform stack in these clusters, right? And that's probably even more expensive than the original cluster cost, right? Just the bare compute to spin up these platform stacks is pretty heavy typically. So why not do multi-tenancy? Why not share clusters, right? That's obviously the opposite approach, and that's gaining a lot of attention in the past couple of years, because I feel like in the early days of Kubernetes, it was all about how do we get Kubernetes in people's hands, right? How do we stand it up as quickly as possible, as efficiently as possible? And cost wasn't that much of a concern. Efficiency wasn't that much of a concern. It was more like, how do we get our applications in Kubernetes, right? And how do we become cloud native, right? And how do we start using microservices and establish a platform team, right? But most recently, cost, again, on the rise. The economy has changed a little bit as well. People probably noticed that, right? So cost is definitely a big factor now, and people are wondering, are we doing this right? So when we're looking at multi-tenancy, we need three things, as I mentioned, right? Workload isolation in these clusters. We need to establish fair use in these clusters of these shared resources. And then we need to make sure our tenants are somewhat still flexible. Because if you spin up, 1,000 clusters and you hand them out to 1,000 teams in a large company, then they can be fairly autonomous in terms of what version do they have. Maybe they say, hey, I need a different version of Istio, or we want this part of the platform stack to look slightly different. Maybe your company can accommodate that, and that's great. In a shared cluster, those things get a lot more difficult. There's, I think, a couple of boxes looking a little odd, but we'll ignore that piece. If we're isolating things in a shared cluster, the first thing we need to do is essentially making sure that people don't break out of these containers, right, and do really crazy things. And so looking at pod security standard is a good way to establish like a baseline of security in your cluster. I would recommend going for the restricted policy rather than actually the baseline policy, which is another approach to introduce pod security policies. But what this is essentially doing is, admission control, on these pods that get created, and you're restricting, host access, privilege escalation is something to prevent, right? And a whole bunch of other things people just don't do crazy things with containers in that shared cluster. And it's obviously much more important in a shared cluster, but it should kind of be the baseline today in pretty much any cluster anyway. You can obviously add custom policies to the mix by things, like Open Policy Agent, Kivano. We have a little project called JS Policy as well that makes things a little bit easier. Regardless of what you're choosing, right, policies are pretty key and a starting point for even, making sharing possible. The second thing we want to look at is network policies, right? And you can see on the right-hand side always the kind of resources and how they're built up and how to set things up. The first thing I would do in terms of networking is deny everything internal, right? Which in network policy terms you kind of have to actually turn around to allow everything except internal IPs, because what you probably still want applications to be able to do is access the internet, right? I know in some regulated industries you don't want to allow that either, right? And then obviously your cluster may even already be air-gapped, and even though that policy may allow it, the cluster itself just doesn't have the network connectivity. But in general, I would say prevent internal traffic is a good baseline policy to start with. Expanding from there, you would typically allow connectivity within the same tenant. So if you have a tenant with a single namespace, you would essentially say, hey, within that single namespace that I'm handing out to tenant one, they should be able to freely communicate. Makes sense, right? Because they may have several pods in the application communicating with each other. Obviously, we don't want to be in the way. A nice way is also if you have multi, namespace configurations. So you have tenants doing things across namespaces, right? You can obviously work with labels to make that happen as well. The next thing I would recommend doing is allowing DNS servers. Because if you don't allow DNS servers, they probably don't want to talk to Google's IP addresses, right? They probably want to send a request to google.com or stripe.com or whatever the APIs they're using. And at the same time, there's also cluster internal DNS. So you want them to reach your internal DNS service as well, right? So if you have core DNS or something like that running in your cluster, right, your cloud provider is offering that, then typically, that's something you want to allow. Obviously, you can restrict this you can see here, the first network policy we set up to deny everything, internal. We actually allowed an IP block. We allowed everything, and then we set except, and then all the internal IPs, right? 127, 16, 00, etc., right? And for ports, if you're looking at the bottom section for DNS servers, we could do the same thing, right? We could say, hey, restrict this only, to our internal network and allow this, for example. If we're saying, hey, Google's DNS servers should not be used in this case, or we're kind of proxying to them through our DNS server. The last part here is And that's obviously optional as well. Like all of these are kind of, recommendations of things you can do. You don't have to do all of these. But giving your tenants access to the Kubernetes API may be helpful, right? Because they may, start jobs from the application, right? Like maybe there's a, continuously running pod that actually launches jobs for, everything they do in terms of compute. So that is obviously very helpful. I didn't find a great way for this to actually automatically fill in the Kubernetes API server IP address. That would be kind of handy. Maybe that should be a feature request. But for now, you just have to kind of look it up, right? Look at the endpoint. Like there's always the Kubernetes service, right, and default namespace, and you can kind of see like, okay, what is the endpoint behind it? What is the IP of it, right? Probably just use that, right? Is the easiest way to find it out. But it would be kind of neat if this was just automated and you could have something that works in every cluster. Then in terms of nodes to actually launch pods, we may want to assign static nodes. You see here in this pod spec that we're using node name and then some node, right? So we do a static assignment of a specific node. That may be a little bit inflexible, so we may just have node pools instead, where we're saying, hey, please AWS create a node pool with these kind of labels, right? And then in our Kubernetes cluster, we can now say, hey, all of these pods that get started in this particular namespace that belongs to this tenant, or these 3 namespaces that belong to this tenant, should have automatically this node selector. And should have automatically, that's how you go back to like things like Open Policy Agent, mutating webhooks, right? To essentially inject that into every pod that gets created, or every deployment configuration, right? Whatever your users are spinning up here. On-demand VM provisioning is pretty cool as well. There's solutions out there like Kata containers or nodeless Kubernetes, which essentially spin up micro VMs for every container you're launching, right? So if you care about like, things like container breakouts, and you want to make sure that people, like you say, we don't want to segregate by, node groups. We actually want to have shared nodes. Then, container breakouts is something, to look at. And then using something like this is essentially saying, hey, let's just provision the VMs on demand as workloads get created. And these are micro VMs tailored to, the resources that container needs. It's a pretty interesting approach. If you want it even easier, you can go for like a serverless Kubernetes approach. So there's Virtual Kubelet, really interesting project to check out. So basically a node in your Kubernetes cluster that is not a real node. It just looks like a node, and your workloads get scheduled on it. And then it does the, essentially launches the containers somewhere else. So for example, they support things like nodeless Kubernetes, but they also support, Fargate, for example, as a backend. But if you're targeting Fargate, it may actually be even easier because EKS already has a mode where you can say launch containers in Fargate instead of, VMs. And then you don't need to manage EC2 instances and node pools at all. And that's really great because, AWS takes care of all of this now. Google calls us GKE Autopilot, pretty similar, right? Where you essentially can trust the cloud provider in a serverless fashion to run your Kubernetes clusters. Because really, all the Kubernetes does is a lot of abstraction. And do we really care about managing nodes? We really don't, right? What we care about is the Kubernetes API and how we specify workloads, right? And that whole way of declaratively defining what should be running. But we don't really care what happens under the hood. The next thing we should do is, ensure fair use, right? So people have access now. How do we make sure they don't overuse resources in a cluster? And, one thing to consider here is like, every pod gets an IP address. So IP address space is limited, at least, as long as we're not using IP6, everywhere. So we should limit that, right? Secrets and config maps are a little bit more loose, I would say. Like there's obviously a lot more, like there's not a hard restriction in that sense, but still if somebody's spamming the API server with a lot of like config maps and secrets, right? There was actually a talk by Adobe, I think like 2.5 years ago, where they brought down a cluster, with like, hey, faulty controller that was spinning up 1,000 secrets per second or something like that. And that's a real danger, right? That obviously you can solve things like this with rate limiting as well. But that's definitely something to do. You can limit pretty much any resource, not just the standard, pod service, etc. Any resource, custom resource definitions as well. Limiting the number of node ports, maybe forbidding that in general. Limiting load balancers. You probably also don't want to pay for like a bazillion load balancers is a pretty good idea. And then hardware resources, right? So for each container, we can specify a requested amount of resources and the actual like upper limit of resources that should be used. So that allows us to do a little bit of like oversubscription, that we have these two different methods. But we should have limits in place for both, essentially, to ensure fair use in a shared cluster. Let me just quickly check the time. Okay, we're doing fairly well, halfway through. The other thing we want to do is probably introduce a limit range besides the resource quota that we just constructed. What a limit range essentially does is, three different things here. The first thing is we're setting defaults, right? Is a default limit. So if you just create pods, then they may not. The engineer may not have specified, the resource use, and you can obviously have that fail, right? And your admission control just kind of denies that request. But now you're putting, that burden on the engineer to kind of think about, what should I use here as like CPU and memory in my Kubernetes? They may not know, right? So having some sane kind of defaults as a starting point may just be easier. And to just limit resources and request resource by default. And then the second thing a limit range can do is define the range, right, for these limits. So essentially setting minimum and maximum limits for these resources, right? So that people, can't like say like I want like 100 million, CPUs in this cluster, because they may not be available. I actually don't know what happens when you create something. I should try that out in EKS, because I'm not sure what the biggest machine is you can provision in EKS, but there probably is a physical limit to what you can do. The other thing we obviously want to do is establish tenant autonomy, right? So we want to give them a space to work in. And, I already said it, kind of like space, namespace, right? It's pretty close that is the construct that a lot of folks are using. A namespace essentially prevents naming conflicts. That's already great, right? Because if we didn't have namespaces and we had two tenants that created a pod called database, which is kind of likely, that they create something like, or app or API, right? Things like this, that would be really annoying, right? If you always had to say my service API, right? With a namespace, pretty straightforward, right? You can essentially say, hey, we have 3 namespaces. That's our tenant group, right? And we segregate things even within our tenant, but also we don't have to care so much about what everybody else is doing. The other thing that's great is many isolation controls, as we saw earlier, are namespace based, right? You saw that earlier, the network policy, the resource quota, the limit range, right? All of these objects are namespace-based resources. So we can essentially define them on the namespace level, and that makes things quite easy. You saw that earlier, right? There's a network policy, there's the limit range, there's the resource quota. Many tools also provide an easy way to filter things based on namespaces. So if you're thinking of like a Grafana dashboard, right, or things like a Datadog, right? It's pretty easy to say like, hey, give me everything in that namespace, right? And that is pretty helpful for people to kind of observe things. So the namespace really is the tenant's realm, where they should be able to do things. And then there's other namespaces that run, your Istio, et cetera, which they may not, be able to touch. But what about multi-namespace tenants, right? I was referring to this a couple of times. That's obviously an interesting concept. But some of these resources, as we saw earlier, I think I just showed that on the last slide, right? A resource quota, so resource limits defined per namespace. Now you have a tenant that needs 3 namespaces. So how do you divvy it up? Do you do a third in each namespace? Those kind of scenarios get a little ugly, right? Because that may not be the split that the tenant prefers, right? But saying, hey, this tenant needs 3 namespaces, that's why they have 3x the limit is also kind of weird, right? Because that namespace is just a logical boundary ultimately, and not like a actual resource boundary. So things get complicated. At the same time, we also have like, we go from one config to multiple configs per tenant, right? So we're essentially not like in the previous example, where you saw like namespace, like network isolation with network policies, right? You can have one policy and then you can kind of, just push it out in n namespaces and can say like, hey, we standardize for everybody. There may be exceptions that we're making, right? But there's one general policy. If you now have these policies that have to go, this one has 3 namespaces, this one has 2, right? You kind of have to do it custom, which is a little bit more effort and a little bit more complexity. So the complexity grows with number of tenants if we have these multi-namespace tenants. But a lot of companies have these multi-namespace tenants or want to have these multi-namespace tenants because that's a great way, especially if you're setting up, strict network policies, et cetera, right? And you have folks that want to, deploy multiple things, microservices, et cetera, right, that communicate with each other. It's pretty useful. What about cluster-wide resources? That's another big thing in terms of autonomy, right? What if one of my tenants wants to explore Argo CD, right? And that is not a widely adopted pattern in our company yet. Like, maybe Argo CD at this point is, right? And the platform team provides it, but what about the next tool that is being built, right? And don't I want my best people to, move forward and kind of innovate and autonomously say, hey, we've been exploring this should become a golden path in our company, so we documented it, right? But in order for them to do that, you need to allow them to be able to run a Helm install of that software, right? But if that software is like Argo CD and has custom resource definitions, right, they need to have cluster-wide access. The namespace is just not going to cut it for them. And controllers is the same problem, right? Anything that has just larger access, or let's say they want to set up their own network policies and say like, hey, we should make it a best practice to narrow this even further down, right? Or set up RBAC for our Helm charts, right? And we played around with this. It's just really hard to give them access in a namespace-based multi-tenancy world. So all of these situations can be taken even further to even like control plane flags. Somebody wants to test the alpha feature in Kubernetes, the Kubernetes version itself, right? Maybe even the distro, right? There's so many things that you just won't have access to in a shared environment where you're pretty limited. So should we go back to this scenario? Sounds like multi-tenancy is kind of like, I don't know. Maybe single tenancy is the right approach. And that's how a lot of companies feel, right? They embark on this journey because of efficiency, because of cost reasons, right? And then they start to see, separate clusters did have their benefits. That's why we got vCluster started. What you can do with vCluster essentially, instead of giving people that namespace, right, or these 3 static namespaces, what you do is you deploy a vCluster into a namespace. And now you hand out that vCluster's API server IP, right? So when you look at the kube context of your tenant, they don't talk to the EKS cluster anymore. They talk to that virtual cluster pod, right? And that virtual cluster pod gives them the feeling of having their own cluster, and they can be admin in that cluster. So they have full autonomy. And what happens under the hood is that vCluster has a separate state from the underlying cluster. So if I create 5 namespaces and I create deployments in there and I create RBAC and I enable Kubernetes alpha flag in that API server, none of that affects the underlying cluster because it's just this virtual cluster container that it affects. And when I create resources, they live in the state of that container. They don't live in the underlying cluster. I create namespaces. They don't exist in the underlying EKS cluster. I still have that one namespace and that one pod. But the thing that actually gets created in the underlying cluster is the containers themselves. Because we all know that, like Docker and Docker and like Kubernetes and like all of these approaches, they have pretty big downsides regarding, performance and limitations of what you can do, right? And then how do you want to connect to native AWS services, right? Like there's a lot of these kind of problems that come up that you may not see at first when you use something like Docker and Docker, et cetera. And then you may need, privileged containers to set it up. So when we built vCluster 3 years ago, we were like, let's definitely not do that, right? That's just going to lead to problems. So what we do instead is we launch the actual containers that get created in these virtual clusters in the underlying namespace. So when you see that EKS cluster as a cluster admin and you have 50 tenants, you're going to see 50 namespaces, and you're going to see all the pods of these tenants split up by namespace, right? But these pods may run in 8 different namespaces inside the virtual cluster. And for the tenant, that's how it looks. But for you as an admin, it's 10 pods in one namespace instead of 10 pods in 8 namespaces, right? And that's a really cool thing because we basically just have namespace-based multi-tenancy, but we don't have to worry about multi-namespace tenants, right? Because one is enough and the virtual namespaces are enough. And at the same time, they can be full admin. So if they need an Argo CD, they install Argo CD to their cluster, totally fine. All of these CRDs and virtual objects, they all just live in the virtual cluster. The only real thing exists in the underlying cluster as pods, right? That's the only thing you see. So everything we talked about earlier, you still need, right? But then you elevate the tenant experience with virtual clusters. That's essentially the idea. And you get more resilience as well that way because, as I said earlier, if you have the situation where you bring the etcd down because you're spamming it, somebody may just do that on accident, right? In this case, they bring their own etcd down, right? Not the entire underlying EKS cluster. So other tenants are not affected by these requests. And it also serves kind of as sharding of the API server, right? Because when you're running really large multi-tenant clusters, one of the bottlenecks actually is Kubernetes itself, right? And if you think back of the early days of Kubernetes, it was always like, how big can I get, right? How many nodes can we add? How many pods can we create, right? I mean, on the way, we somehow forgot that and went to like, let's just create these 3-node clusters, right? And these very inefficient little clusters. But that's how it all started, right? It was like every couple of months, oh, we hit this major new milestone. Kubernetes now supports so and so many pods, right? But there are limits to it of what that API server can do, what that etcd can handle. And with virtual cluster, you have this sharding effect. So you can actually scale much further. So we have fewer real clusters that are larger now, which is great because your IT departments are typically great at running, these large clusters. A lot of software is optimized to run like this. Then we have super lightweight virtual clusters as this layer, in the middle to create that experience for folks. And then now we have that shared platform stack. And that's where we can provide certain resources, like, for example, Istio, right? Or Cert Manager, right? For all of our tenants. But if one of these tenants says, like, I need to roll my own, OPA because I want to play around with it, they can still do that. So everything they do in the cluster will go to, through 2 admission control loops. Their own OPAR, right? Their own RBAC, their own network policy, and then again, the one in the underlying cluster, right? So they're not elevating their privileges. They're actually just locking themselves even further down, right? Which is great. Let them do that, right? Let them explore this. And that's a lot cheaper, this approach. It's one of the main reasons why people get started with this journey. So it's really control plane per tenant. It's full cluster access for your tenants, reduced complexity in the host cluster because all you have to worry about is pod security ultimately, right? You don't have these CRDs and like, this tenant wants this version of a CRD, this tenant, needs to stay behind on my Argo version, right? You won't have these problems anymore because you're kind of offloading that into the virtual clusters. And you have a fast, lightweight, and cheap way to spin up clusters effectively. And it's a certified Kubernetes distro. So, ideally, you can start handing out virtual clusters instead of EKS clusters, and your tenants won't even notice. Like, we have some folks do that, right? And it's surprising how well this works. Okay, sounds great. You can deploy a virtual cluster via the CLI, as I showed earlier, as I showed here in this example. You see on the right-hand side, we do have a policies section, and there's a whole bunch more to configure in what we call vCluster YAML. It's basically just the values YAML, right, for the vCluster Helm chart. It's essentially just a Helm chart under the hood. And everything we set up in this talk, you can enable by toggling these 3 things to true, right? So that network policy you saw earlier, we actually, when you do it via the CLI, we actually find out your Kubernetes API server and like those kind of things, right? Or we wired up to only talk to the virtual cluster instead of the host cluster. Resource quota you can enable, limit range you can enable, and there's a whole bunch more you can just enable by toggling it to true. But obviously you can customize everything, right? If you're saying like, hey, these defaults, in terms of CPU and memory, we want to change that, it's all tweakable. If you're interested in this topic and you want to learn more, obviously I'm here the whole day, so just come up to me. We have a little bit of a corner up there, a little desk as well, so just look out for the bright orange vCluster and come talk to my team. At the rooftop level, and online you find us at vcluster.com, and obviously the source code is on GitHub. All right, that's it. Any questions? Thank you. Oh, and I missed this last slide. We're also a fun team and always looking for talented engineers. So if anyone's interested, look at our careers page. Thank you.
Folks can feel free to, I think, ask questions or come up and...
Yeah, of course.
Yeah.
Sure.
So, one second.
Does it affect the pods in the tenant cluster?
Sorry,
if I go delete the pods in the underlying cluster, does it affect the pods running in the vCluster as well?
Yes. So what would happen is, Kubernetes, everything is like you describe the desired state, and then Kubernetes figures out the way to get to the desired state, right? If the desired state in the virtual cluster is to have a pod running, and then you go into the underlying cluster and kill it, it would recreate another one in the underlying cluster, right? It's like a replication controller, essentially, replica controller.
Yeah, it's a good one. Assume it is compliant and it does recognize any external autoscalers. Like if I go for a Carpenter or Cast AI, would it honor its applicability and presence?
That's actually... Yeah, that's actually a good point. So a lot of them work on the replicas, right? Rather than the actual, they don't just copy pods, right? They scale up the replica number typically. So you would actually run that inside the vCluster rather than in the host cluster, right?
Okay, a follow-up question. You said replicas. So with auto-scaling, basically it's the two types, right? One is the horizontal autoscaler, and one is the cluster autoscaler.
Yeah.
I mean, coming from the cluster autoscaler.
Oh, you're talking about the cluster autoscaler. Yeah.
Not the HPs. HPs, I get it. How?
Yeah.
But if we're married to a Carpenter or a Cast AI, I'm focusing on cluster autoscaler because the cluster will only autoscale when HPs hit the limit and you have no really space to grow. And that's where the cluster autoscaler will come in the picture and add a new node. That's what it does on a cluster. It adds a new machine, a new node, without any node groups and node pools. I saw that vCluster relies on these node groups. So I'm just thinking, because I do continuous strategy for my organization, and we're moving away from a default cluster autoscaler, onboarding Carpenter. Might look at Cast API as well. So getting that in place, if I'm looking at vCluster, because multi-tenancy is another, it's like an Achilles heel for us. We do similar things. On-prem, we have a multi-tenant cluster, namespace based. On cloud, we want to move towards CKS. But if I get in vCluster, only things that come to my mind, would it honor the existing autoscalers that I have?
Yeah, we actually recommend that for everyone we speak with to have the underlying cluster autoscale, because then you get the real nice benefits of the virtual cluster. In fact, when you look at our commercial offering that's obviously built on top of the open source vCluster, what it does, it actually puts virtual clusters, we call that, to sleep when they're not being used. And the really great thing is, during the day, your cluster may have 80 nodes, and then at night, when nobody's talking to these virtual clusters API servers, we monitor the network traffic, ingress traffic, as well as it's kind of like an API gateway in front of the virtual clusters. So any kind of API requests to the virtual cluster, as well as any kind of ingress traffic, we can see, hey, nobody's really touched this cluster in 30 minutes, right? So we actually scale it down to 0 by literally setting the replica numbers to 0, but the state obviously is still there, right? But the entire cluster is kind of gone. You can't really do that with a real cluster, right? Because there's always something going on, right? And it's really hard to scale it down to 0 because there's your OPAR and your Istio and all these kind of things running. But in the virtual cluster, it's typically only application-specific things running, right? But what you should definitely do to get the cost savings benefit of this sleep mode is to have the underlying cluster autoscale, right? Because otherwise these nodes are still around, right? Still paying for it, right? So it's a pretty common scenario.